Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. My name is Muhammad Ilman Mubni. In this morning, I want to tell you about my synopsis about optimization of pressure vessel. With the title of Design and Optimization of Pressure Vessel to reduce cost production by reducing weight with adequate strength and stiffness. So the objective of design optimization of pressure vessel is cost reduction by reducing weight with adequate strength and stiffness still. So technically, the conventional design aims at finding acceptability design which merely satisfies the functional and other requirements of the problem. So when you design something, there will be more than one acceptable designs, and the purpose of design optimization is to choose the best one. In this uh, in this topics, works parameters such as the thickness of the shell, thickness of the dish end, or we can call it the head of the pressure vessel. Also, the length and the radius of the pressure vessel are optimized by using an colony optimization or AECO. Has been shown for a pressure vessel problem with 4 variables and 4 design constraints. And it is found that the results obtained from AECO are better as its search is for global optimum as against the local optimum in traditional search method. The results of the AECO have been checked using ANSYS, and it is found to perform satisfactorily. So, what is my motivation in choosing these topics as my big assignment? So, in my opinion, the discussion about pressure vessel has somehow always been interesting to me. I started getting to know this equipment since I was studying for a diploma, and the topic of my final project was dominated by the discussion about the pressure vessel as well. So I have more attention, and yeah, it is take an attention of mine and interest of mine in this pressure vessel. So that in this big assignment regarding optimization, I took the topic of the optimization of pressure vessel. So basically, a pressure vessel is a closed container designed to hold gases or liquids at a pressure substantially higher or lower than the ambient pressure. It is commonly used in oil and gas industry or maybe petrochemical industry because it works in very critical conditions, namely high pressure. Several parameters need to be considered when designing a pressure vessel, such as material selection, required thickness, minimum thickness, MAWP or maximum allowable working pressure, and others. So the objective are the first one is design a compressed air storage tank with a working pressure of 1000 psi and a minimum volume of 750 cubic feet. The second of all, minimize the manufacturing cost of pressure vessel by reducing its weight with adequate strength and stiffness. And the last one is optimize using an colony optimization approach or method to obtain optimum design parameters for the pressure vessel. So the objective minimization of cost by reducing weight of pressure vessel is achieved. So here is the model of my problem. So it is basically the drawing of the pressure vessel, and typical input data required to develop a mathematical model for a pressure vessel design is pressure vessel material. So the material of this pressure vessel will be SAE G2340 with the type of 830R. So here are the mechanical properties and the design properties of this pressure vessel. The first one is modulus elasticity with the value of around this. Then the yield strength, factor of safety, the allowable yield strength. Then the applied pressure, or we can call it uh, working pressure. It's about 1000 psi. So from this pressure vessel material, we can conduct uh, the mathematical modeling like this. So uh, the representation of this mathematical model is for the first one is x1, or the radius of the shell, then the x2 is the length of the shell, x3 represent the thickness of the shell, the last one, the x4, is the thickness of the dish end, or the head. And the design variable is about radius, length, thickness of the shell, and thickness of the head. Then the design parameters, it is about the circumferential or job stress. Then the second one is longitudinal stress. The third one is volume. Then the last one is length. uh, I think it is one more thing that I forget to put it on. It is about the design constraint. Yeah, it is similarly about the design parameters. It is about Hooke stress, longitudinal stress, volume, and length constraint. So the expected results of this experiment, I think. So the first one is obtain the optimum design parameters of the pressure vessel to reduce its weight. So according to the number one, the number two is so we can minimize the manufacturing cost of the pressure vessel. Then the third of all is provide the graphical result from mentioned optimization method, or we can, as I mentioned before, is about end colony optimization between the iterations and cost. Then the last one is the comparison between the previous works using various other optimization methods. Then for the end colony optimization, maybe I will explain to you all briefly about this method. So basically this method is inspired by the behavior of the end. So for the example is when you put sweet things or sweet food in the table, so oftenly there they there will be some ants with which uh, uh, swarmly around your foot, and then from their nest they will make a path. They will make a path from their nest to the foot. So for the instance, it is like this. So the first one, there will be nest and foot, and then the end will be walking through the nest to foot, and then they will make a path through uh, from the one location to uh, the end, the last location, to the proposed location. Yeah, like this. It is yeah. So it is an example of the behavior of the ant or the insects. Then for the analytical approach in this method, it will be using like this. Yeah, actually, I'm still learning about it, progressively learning about it. So for the solving method of my problem in these topics, I will using uh, the n colony methods. Yeah, I think sort of like that. Okay, maybe that's all from me. Thank you everyone. Assalamualaikum warahmatullahi wabarakatuh.